All right, welcome back. We are getting ready to talk about example 5, which is a sports application. So what this says is a player throws the ball from first base to a point located between third base and home plate and 10 feet from third base. What is the distance of the throw to the nearest 10th? All right. So this is baseball, right? So in baseball, you have home plate, you have first base, second base, and third base. So what we're going to do is we're going to put this problem actually in a coordinate plane, which means we're going to give home plate, first base, second base, and third base, we're going to give them ordered pairs. So home plate, we're going to call that our origin. So that's going to be 0, 0. First bases, all the bases are 90 feet apart, right? And it kind of makes a square. So first base is 90 feet this way in the horizontal. So that's going to be 90, 0. The y part's going to be 0. Then second base is directly 90 feet this way. So this is going to be 90, 90. And then you go over here, which is just 90 feet up for third base, which the x part is 0, but the y part is 90. So there we go. Those are our ordered pairs for the bases. Now let's go ahead and look at what this says. So a player throws a ball from first base. Okay, so from here, this is where the ball is, and to a point located between third base and home plate. Okay, so we know that the point where they're going to throw is between here, but it says it's 10 feet from third base. Okay, so if it's 10 feet from third base, that means that this is, what is this, 10, 20, 30, 40, 50, 60, 70, 80, 90. Yeah, so 10 feet from third base would be at 80 feet, right? So that would be the point 0, 80. That's not an 80, that's an 8. So 0, 80. 0, 80. I don't like the way that looks. 0, 80. Okay? So, if I had a little ruler, I could make a very beautiful straight line. Okay, so this is the path of the ball. It's going from first base here all the way to here. Okay, so we need to find that distance. So we could use the Pythagorean theorem or the distance formula. I'm just going to use the distance formula. So the distance formula would be, distance formula, they're going to write that in symbols, right, is the difference of the x values, x2 minus x1 squared, plus the difference of the y values, y2 minus y1 squared. And I'm going to call this my x1, y1, and this is going to be my x2, y2. And then I'm just going to substitute those values in to this equation. So we get the distance equals the square root of x2 is 0. Oh, that's nice. Minus the x1 is 90 squared plus y2 is 80 minus y1, which is 0. Oh, this needs to get longer. Okay, so then we end up with the distance equals 0 minus 90 is a negative 90 squared plus 80 minus 0 is just 80 squared. And then we just need to figure out what those are. Okay, negative 90 squared, negative times a negative is a positive, right? So 90 times 90. Okay, so 90 times 90 is going to be the same thing as 9 times 9, which is 81 with 2 zeros. So 8100 plus 80 times 80, which is going to be the same thing as 8 times 8, which is 64, and then you put those 2 zeros there. So 6400. Then we just need to determine what that is when we add those two together. So 8100 plus 6400, that's 0, 0, that's 5, that's 14. So, oh my goodness. Oh my Lanta, it's a really big number. D equals the square root of 14,500. Yeah. And it's saying to the nearest tenth. So for this one, we're just going to go ahead and take out our calculator because this is a very, very big one. So we're going to go the square root. Where is my square root? Okay, there it is. 14,500 is 120.4. It says round to the nearest tenth, right? So we look at the hundredth. That doesn't round that up, so it just stays there. So our answer is oh my goodness, why do I keep on hitting it? Okay, so the distance is 120.4 rounded to the nearest tenth. And what are we talking about? Are we talking about feet? Yeah, feet. So, yeah, there's our distance, 120.4 feet. And what is the distance of the throw to the nearest tenth? Yeah, so from first base all the way there, 124 feet. Okay, cool. Let's go on to the next example here. It says the center of the pitching mound has coordinates 42.8. 42.8. When a pitcher throws the ball from the center of the mound to home plate, what is the distance of the throw to the nearest tenth? Okay, so we're going to kind of do the same thing. We're going to set this up in a coordinate plane again. So I'm just going to do it real rough, not as fancy and nice as that one. So remember, home plate is right here, and this is our home plate. This is our 0, 0. And it's basically just saying when the pitcher throws the ball from the center of the mound to home plate. Okay, so center of the mound, we're just going to call it right. This is going to be the center. And we're going to call this 42.8, 42.8. That's what the pitcher is. And really, we're just finding this distance from the pitcher to home plate. Right here. Just that distance. Okay? So, to the nearest tenth. So, it's always really good to highlight that. I didn't do that on the problem above, but I should have. So, what is the distance of the throw when the pitcher throws the ball from the center of the mound to home plate? What is the distance of the throw? Okay, to the nearest tenth. So, we always want to remember that, to the nearest tenth. Okay, so let's go ahead and do the distance formula, right? Distance equals the square root of the difference of the x values, x2 minus x1 squared, plus the difference of the y values, y2 minus y1 squared. We're going to label these. I'm going to call this my goodness, right over here. This is going to be my x1. This is going to be my y1. This is going to be my x2. This is going to be my y2. And then I'm just going to substitute those values into my equation. And I get the distance equals x2 is 42.8 minus x1 is 0 squared plus y2 is 42.8 minus 0 here. Yeah, and then we just simplify, right? So order of operations says we have to do the parentheses first. 42.8 minus 0. That's nice because it's just 42.8 squared. Plus, same thing here, 42.8 squared. Then we just need to figure out, well, what is 42.8 squared? Well, that's the same thing as 42.8 times 42.8. So I guess I'm just going to go right here. 42.8 times 42.8. Okay, 8 times 8, 64. Write the 4, carry the 6. 8 times 2, 16 plus 4 would be 22. Write the 2, carry the 2. 8 times 4 is 32 plus 2 is 34. 32 plus 2 is 34. All right. And then 2 times 8 is 16. Write the 6, carry the 1. 2 times 2 is 4 plus 1 is 5. 2 times 4 is 8. And then I'm in the hundreds place, so I put 2 zeros. 4 times 8 is 32. Write the 2, carry the, make that a 3. 4 times 2 is 8 plus 3 is 11. Write the 1, carry the 1. 4 times 4 is 16 plus 1 is 17. I just add up all these beautiful numbers and I get 4. And 2 plus 6 is 8. And then we get 9, 11. Write the 1, carry the 1. And then I'm going to find 10, right? So 8, 1, and 1, that's 10. 10 plus 3 is 13, right? The 3 carry the 1. 1 plus 7 is 8, and 1. Then we have to figure out how many decimal places. So there's a decimal place, there's a decimal place, that's 2. So we move over 2 decimal places, and then we have our number right there. The distance equals the square root of 1,831.84. Okay, oh, that's really shaking. So we just need to figure out what the square root of that is. I'm going to go ahead and check my 42.8 squared real quick, just to make sure. 42.8 squared. And yeah. Is that, wait, what does it say? Yeah, 1,831.84. So that's perfect. And then we're just going to take the square root of that. Oh, wait, I'm tripping. Okay, that's what one of them equals, right? So 42.8 squared is equal to this. Plus, we have to do this, which is the same thing as this. Okay. All right, right, because 42.8 squared is this, plus 42.8 squared is this. Then we need to add these two together. All right. We're going to add both of these numbers together. We get 8, 16, that's 1, 2, 3, 6, 8 plus 8 is 16, carry the 1, and that's 3. So there we go. The distance of those is 3,663.68. Now I take the square root of that. Okay. All right, so clear that out. The square root of 3,663.68. Close the parenthesis, hit enter. And I get this. And what do we have to round it to? The nearest tenth, right? So 60.52. We look at the hundredths, and the hundredths is a 2, so that doesn't round that up. It just leaves it right there at 0.5. So our answer is 60.5. So the distance is 60.5 feet. Yeah, I think we're talking about feet. Huh, okay. 60.5 feet. And, you know, we have to think about that just for a second. So I'm trying to process, right? So this ordered pair is, this is the x, right? So it's 42.8. That means it's x 42.8 feet this way, and then the y means it's 42.8 this way, right? That's why it's that ordered pair. So I'll use a different color. Let's use green. So this is 42.8 feet from here to here, and this is 42.8 feet from here to here, and this is our right angle, right? And so these are the legs. This is the hypotenuse. The hypotenuse is always bigger than the legs. So yeah, so that makes sense. Our number has to be bigger than 42.8. So there you go. That's how you do that particular problem. All right. Well, great job, and we will see you next time. Goodbye.